All right. You got those forms? Let me make sure I got, let me see if I got it. Let me make sure y'all got everything filled out. Let me take a look. You didn't know your card number, Nate?
Yes, sir.
All right, Module 2, Healthcare Facilities. Session 3, Wiring and Healthcare Facilities. Section we're covering tonight, 3.00 through 3.52. What we'll be doing. So, homework. We need to go over homework, don't we? So, Module 2, Section 3 is what we need to go over. Module 2, Section 3, you got those? Y'all got those? You got those?
Yes.
I did not bring the thing to do it on the board tonight. We'll go through it without doing it on there. All right, so, in fact, I'm going to go ahead and, before we even start, I'm going to go ahead and give you, this will not be due next week. This will be due week after next. This is Module 3, Section 1. Be standby and emergency systems. This will be due in 2 weeks. Go ahead and give it to you so you'll have it. So that's due in 2 weeks. Homework for that. Next week will be our test on Module 2. So we'll go over that tonight. We're going to go over homework. We're going to go over Section 3. We'll review for the test, and we'll do some review questions. So we've got a lot to do, try to get through here, but I don't think it takes that long. So, safety topic that I had actually listed for tonight, being that you might be working in a healthcare facility, which would be in a kind of maybe a multi-story environment. So if you actually had access to being able to work on something other than a ladder, hopefully, it would be a single-man lift, right? Okay, is that right? So, let's talk about safety for a single-man lift. Or let's just talk about a single-man lift in the job situation there. So, what do you think?
Make sure it has outriggers.
Outriggers?
On level ground.
Level? Okay. Because single-man lift, usually not, you know? Got to be level to use it, right?
Be real careful when you're moving it,
Moving
especially if it's an active healthcare environment. You gotta make sure you probably have one guy actually moving it and then spotters, especially around corners and stuff.
Around corners. But usually, let's say we environment where you don't want to tear up the door or the wall or whatever, right? Okay. You don't want to move it in a raised position. Might be sprinkler heads. You know, that's one been always my fears of having something raised and hitting a sprinkler head and knocking it off. You know. So, what else about it? You think you're typically going to have to tie off on one? Probably more than likely, aren't you? Because most of them, a lot of days now, is what, over 4 foot or something? You got it
It's 6 foot.
6 foot, 6 foot, okay. So you probably would be tying off on it. How would you tie off on a single man lift? Like, let's say here, if you're working in this environment right here, what would you do? Would you tie off to the ceiling grid?
I'd open the ceiling tile up, see if there's anything.
Try to find a bar joist. Okay. So it can become a little, so in an existing environment, it may be smarter to use a ladder, even though you don't like climbing up and down one, right? In the long run, it may be advantageous to use a ladder sometimes, even though we don't think we need to use a ladder anymore. So, but if we do use one, then that's the case. So that's single man. Anything else? How about just care of it? Charge it every night? Comes important, doesn't it? Okay. How about the lift that you're using, how about loaning it to somebody else on a job, another company?
Probably not a good idea.
Probably not. Okay. Why not? What happens if they get hurt on your lift?
So you,
Yeah. So, even though we like to do that sometimes, it really probably isn't a safe thing, really isn't a good thing to do on a job, is it? To use somebody else's rental equipment.
And the way I look at it is and that and ladders and other companies buying their stuff, I mean, they're a professional company anyways, really, they should have the overhead to afford that kind of
Let's
stuff.
do that, yeah. Ladders, same thing. You don't want to loan your ladder to another company, right? Something wrong, he falls on it, guess what? They're coming after your company. Faulty equipment or something of that nature. So even though we like to be the nice guy sometimes on a job and like say, hey, you know, yeah, let me help you out, or let me do this. And, you know, the best thing you can do is, like, let's say if you wanted to, particularly, let's say digging or something, they got a piece of equipment on a job that maybe you're gonna need a hole dug or something, is let them use their equipment and work it out with the office, or we could just pay them with them using their equipment. Don't y'all agree? That's the smarter thing, rather than you jumping on their equipment. Even if you're an operator, like James, I know he is, but you don't want to get on somebody else's rental equipment and start running, break it, and then all of a sudden, they're coming again. We're having to pay for it, something we ain't even got. So there's ways of being smart about this. So single man lift is one of those things, you know, most people don't get them, but everybody wants to use them when they're on the job. But it beats climbing up and down a ladder. So you have to be careful of that. Make sure they're locked up at night. Is another thing. Taking controls with you if you can. Keep other people from using. And there's a ways around all that stuff. So, all right, Module 2, Section 3. I'm just gonna let y'all read them. We got questions we got answered here. 20 questions. So we'll start with 8 and we'll work our way across and then come back. This is reviewing Section 3, which we want to go over tonight. And of course, the purpose of this homework is to make you actually read the homework, read that section, hoping you've done that homework before you come in here, fill this in, because that kind of gives you, used to what we're fixing to study. So, kind of gets you an insight there of what we're going to study tonight. So, that's the purpose of my homework. Doing this every time is, something I've created each time or each week, just to help you be a little bit familiar with what we're talking about. As far as in the book, we're actually on page 18 under our section 3, wiring in healthcare facilities is what this section is called, wiring in healthcare facilities. And so that's what we're going to be covering when we go over these questions tonight. Nate, take the first one.
In any anesthetizing location, all metal raceways and metal sheath cables and all normally non-current carrying conductive portions of fixed equipment, electric equipment, must be connected to an equipment grounding conductor per NEC section 51762.
Okay. All right. So what is that equipment? What is that word, that big word you pronounce there? What is that?
Anesthetizing,
Yeah, what is that?
putting you under, put you sleep.
Putting you under, right? And so what's going to happen when you are put under? You're going to be what? Attached to that equipment, aren't you?
Right.
I mean, They gotta put it on you to make you go to sleep, right? Oops, that pen ain't no good. And so therefore, any equipment that we're gonna be attached to, what's very important? That it be what? Be grounded, right? And so you can see there, that's really what that is talking about, isn't it? That rule is talking about there, isn't it? Okay. If you read it there, metal sheet cable, all normally non-current carrying conductor portion of the fixed equipment must be connected to an equipment grounding conductor. We want everything to be grounded. Everything to be grounded. And I say in that area where we're doing that, where we're getting put to sleep, that's very important. Usually a different doctor that actually does that for you, and they're a specialist. That makes you get another bill when you unless a different doctor. Okay. All right, number 2. Cam, help me pronounce it there, Nate.
Anesthetizing.
Anesthetizing. Okay.
Locations are divided into hazard, classified location with flammable or non-flammable. Anesthetizing.
Anesthetics.
Aesthetics may be interchangeable use in other than hazard location where only non-flammable aesthetics are used.
Okay. So we got flammable and non-flammable anesthetics. So you could have both. Okay. And it says it may be interchangeably used. So you need to keep that hazardous location. If you've got anything that's flammable, of course. We'll be talking about that a little bit as we see in the book there. Number 3.
Attachment, plugs, and receptacles in hazardous locations must be listed for use in Class 1.
Yeah, and that next word should be group. I left that in R.
Group C hazardous locations and have provisions for the connection of a grounding conductor.
A grounding conductor. Again, we want it to be grounding, and so hazardous location is a Class 1. Okay, that means we don't want in a Class 1 location, we don't want the plug to be to where it could come loose. We want it to where it could be sparking, in those areas. So we got a different type of plug, more expensive plug, different type of plug, locking plug, the different, the ones that are formed, that it's not like the normal plug here. You actually have a different plug and a connector, don't you? They actually match and go together. Okay. So we got to have that. That's a Class 1 location. Okay, number 4.
If an outlet or switch box must be installed in an X-ray area, a lead shield must be molded around the box.
Lead shield. Anybody ever wire anything in an X-ray area? I have. I've done a couple X-ray machines. And again, any box, you try to limit the boxes is what you're trying to do. So you really, as long as you can keep it outside of that area, even if you've got to put a box just on the other side of the wall, it limits you from having to do that. But what it is, they make a lead that's moldable. And if you got a box in the wall, you literally wrap the box in lead.
What about light fixtures and that kind of thing?
I had never had to do that. No, I think it's just in the. That's a good question, but I don't remember having to do anything special with the light fixtures. I don't, but my memory's sometimes not 100%, but I don't remember having to do anything. But there is lead shielding, and it is made, you can buy, put around the box. Number 5.
Any circuits interruptions, even in circuits that low as 10 volts caused by a switch or loose or defective connections anywhere in the circuit may produce a spark significant to and not flame or aesthetic gases.
So you got to switch, because what happens when you do that switch every time? You ever been in your house in the dark? What happens a lot of times when you do that switch? You see what? You see a little arc inside there, don't you? A loose connection, what you going to see? What's it going to sit there and do? It's going to vibrate, you're going to see an arc. So those two things, the switch or loose or a defective connection, can produce a spark. So we don't want that to happen. Even as low as 10 volts can produce a spark. And we don't want that around a flammable anesthetic gas, do we? Okay. Number 6.
Per section 517.160A, each isolated power circuit must be controlled by a switch or a circuit breaker having a disconnecting pole in each isolated circuit conductor to simultaneous disconnect all power.
Okay, all right. So we got an isolated circuit. You got, maybe have multiple circuit conductors that are, you know, we gotta make sure that they're all de-energized, don't we? Okay. So 517, we'll probably be looking at that in the code book in a little bit, but we're just gonna kind of fill in the blanks now. And the next one's kind of interesting. You might not have known this, but the answer to it, I think, is something we need to think about. Okay.
No wire pulling compounds that increase the dielectric constant of a conductor may be used on the secondary conductors of the isolated power supply.
Yeah, because what happens in a wire pulling compound, what's usually in it, probably? Moisture, water, probably, of some sort. You know, it does make it more, you know, gives it a less, what am I trying to say? Friction, decreases the friction, right? So that is one of the rules, no wire pulling compounds, okay? Using a secondary conductive isolated power supply in a medical facility, okay? Number 8.
Transformers and capacitors that are a part of X-ray equipment are not required to comply with NEC Article 450 and 460.
Okay, are not required. Number 9.
Isolated power systems are used to prevent power interruptions due to a signal line to ground fault and to isolate power from any electrical ground in certain critical spaces.
Yeah, and just think about the word, hold on, let me see who this is. The word isolated, I mean, hold on a second. Hello? Yes, sir. I am in room 3 something, hold on a minute.
307.
307, which is, are you out on the second floor? I'll be right back, guys. I'll walk out. So I'm kind of stuck back and forth.
It's kind of scary to think they're putting flammable gases down your throat. Never breathe that stuff in.
See what he found.
What's going on? You all right?
That would be the only one that I got.
Working, man.
Nate is the only one that I got.
Okay. Hey, now, do you,
Yeah, what?
you be checking your email
What about?
just for, the PMR, the education units?
No, I haven't checked. I haven't seen anything about it.
No, it's going, you should be looking for tomorrow. I'm gonna turn all this stuff into that. And
What
then-
I tell you what you might want to do is make copies of those certificates and turn them in.
Yeah, cause those, whatever the hours are, that's on the certificate, that's what your education unit.
Did I give you those, right?
Yeah, I got them at the house.
If you may want to
I'll
make
try
some
to,
copies and bring them, carry them to your office or something.
Shoot me an email. that way I'll be able to, be sure to get it tomorrow morning, it's gonna be sent to you. I think they're like 50 hours.
Okay, and then that'll, cause it's the end of the year, so you won't get all your education, you understand?
Yeah.
I'll do that.
All right, appreciate it.
Thank you.
I need-
Thank you.
I need to talk to you too about, they spelled my last name wrong on my certificate.
Did they really?
Yes, I didn't know who I need, they did. They put an E in instead of A in, did they?
You got an email address?
Yes, sir.
Just write it on here,
All right.
and I'll forward you an email address to somebody who can probably correct it for you.
All right, thank you.
Okay. All right.
All right, thank you.
And so they spelled it how? So
They put
it's
a-
G-O-W, they put E in?
Yeah, they put E in on
So
it.
it's A.
Yes, sir.
That's A. Okay. All right. Okay.
All right, I appreciate it.
No problem.
All right, Nathan, you be safe.
All right, what number are we on? Number 10? Are we on number 10?
Yes, sir.
All right, number 10.
Communication, signaling, data, and fire alarm systems, as well as systems operating on less than 120 volt in patient care spaces must conform to the same insulation and isolation requirements as electrical distribution equipment.
Yeah. So that's important to know that. These other systems have got about the same standards, okay, in these healthcare facilities. Number 11?
Per NC section 517.72A, a disconnecting means of
Adequate?
adequate capacity for at least 50% of the input required for the monetary rating of 100% of the input required for a long-term rating of the S-ray equipment, whichever is greater, must be provided in the supply circuit.
Okay. 50%. Okay. Number 12?
The installation of X-ray equipment requires specialized training in order for the equipment both to operate as intended and to protect patients and personnel from unattended exposure to radiation.
Yeah. So a lot of, they actually usually have specialists that come in just to do, there's usually a group that wires, that actually does the X-ray equipment. So at least the job that I've been on, it's usually a different firm, a different company, and that's all they do, is install X-ray equipment. And it's usually, like I say, there's usually a separate home run. There's got to be a disconnect right there at the unit. There's a lot of rules and regulations. And typically what happens is as far as the ones I've been involved with, electrical company brings it to a disconnect, and usually that company doing the X-ray equipment takes it from that disconnect and does all the rest. So, again, because it's very, again, it's highly specialized, and a lot of things, radiation and all that, that's not something we want to fool with, so. So anyway, specialized training, okay. 13,
Every isolated power system must be provided with an improved, continually fluctuating line isolation monitor that indicates possible leakage of fault current from either isolated conductor to ground
yeah,
or something else.
yeah, so, for any isolated power system, you gotta have that. Okay. Number 14,
Grounding systems are the primary protection of devices for patients.
yeah, grounding, and we know that, very important, okay. Number 15,
Monitors must include a green signal lamp visible to individuals in the staging area,
yeah, go ahead. That's close enough.
which remains eliminated when the system is sufficiently isolated from ground.
Yeah, so they want a signal lamp. When we say individuals in the anesthetizing area, we're talking about people working there, right? We're not talking about me and you sitting there in the waiting room. We're talking about actually workers, people working there. They need to see that, don't they? Number 16,
An isolated branch circuit supplying an anesthetizing location must not supply any other location except as noted in NEC 517.160 A4 little a and b.
yeah, okay. So just for that location, you can't supply any other locations. There are a few exceptions and it's listed there. Okay. 17?
Number of control circuit conductors installed in a raceway must be determined in accordance with NEC section 307.17.
300.17, okay. 18,
For therapeutic equipment, the amperage rating of conductor and the rating of overcurrent protection device must be less than 100% of the current rating of medical X-ray therapy equipment.
okay, so therapeutic equipment. Okay. 19,
All high voltage parts, including X-ray tubes, must be mounted within grounded enclosures per NEC section 517.78 A.
517.78A. And last but not least, number 20.
As a secondary backup, at least one battery powered emergency lighting unit must be installed in every nesting location per NEC 517.63.
Emergency light. I mean, no different. I mean, why do you think you want one in there?
Power goes off, you want to be able to see.
Yeah, you want people to see, particularly if they're in that situation where they're in that area and where they could be, and they could be, like I say, under. So, you know, we definitely want to be able to get them out of that area, don't we? So we need an emergency light. No different than being like in a bathroom, you need to be able to get your way out, so. All right, so that's homework. I'm glad everybody did their homework this time. All right, so glad to see that. All right, so I'm calling no names. All right, let's look at our book, page 18, 19. Let's kind of go through this. As we go through this, I'm going to give you some, as we're kind of going through, I'm going to get two birds with one stone, probably. Then we'll come back and do the review questions at the end. But what I'm going to do as we do it, please take note when I tell you that you may need to know this section, and we'll go back and we'll pick up 2 and 3, 2 and 1 in a minute. But if there's any questions on the test in this section we covered, I'm going to tell you to highlight it. Okay, so wiring 3.1.0 we're talking about, and let's turn. Tell you what, let's get our code book out. The first thing it tells us is what we're doing is 517.60. So let's look at that together. And what's it labeled? Ben Nate's the only one that can pronounce it correctly in here.
I know I can.
My tongue gets all wrinkled up. What's it called, Nate? 517.60.
Anesthetizing location classification.
Yeah, see, he's been taught proper English, see, going over there at Bob Jones, see. So, you know, all in big words.
Well, I just have to,
Uh,
I just look at the word
I
and then
know.
I forget about how it looks and just remember how I hear it.
Yeah, there you go. Okay. So anesthetizing location. And you can see here, you know, there are some rules of wiring, and so we'll kind of be looking at those. So let's stay there in our code book here for a minute. And because we're going to see here, as we see, they're divided, in the book says they're divided into hazardous locations now. And again, we talked about this in one of our questions, whether flammable or non-flammable. Okay. And if you read on down, although flammable anesthetics are virtually obsolete in the United States, so they're not around much. I assume that would be something like laughing gas or maybe, or something that they used to do, I don't know. I can remember having laughing gas as a kid. It was not pleasant, as I remember. The smell was horrible. But the NEC still covers them because they are in other countries that use these codes. Okay? But if you read on down there, in areas where flammable anesthetics are used, the entire location is considered Class 1 Division 1, up to a level 5 foot, because that's probably where the gases are going to accumulate above the floor. They are remaining up on the structural ceiling considered to be above a hazardous location. Okay, so we're only going to get hazardous location up to 5 foot, meaning that's probably where the gas is going to be. And Class 1 Div 1 is in our code book. We won't go into depth as far as what that's concerned, but if we needed to know that, that's what it's classified as. And again, we don't really have that much in the United States, but it is still part of our code. We have to adhere to that. We have to do worst case scenario. So in saying that, under the next section, 3.1.1, wiring and equipment within this hazardous location, we see 51661A, that's what the first thing it refers to, and it talks about wiring within. And the first number 1, it talks about one of the words we've been talking about a lot, isolation. Now what is isolate? I mean, if you just think of the word isolation, what does it mean? What are you doing when you isolate something?
By itself.
Yeah, you're setting it apart, aren't you? By itself. You're isolating, like an isolated ground is you're isolating that ground to where it's separate than from the normal grounding, isn't it? And if you see here, in their code, set that's permitted in 517.160, each power circuit within or partially within a flammable, so the flammable anesthetizing location referred to in 5.6 shall be isolated from any distribution system by use of what? Power system. Okay, an isolation power system, no, excuse me. An isolation power system, so that's part of what our code says. And that's what our book is saying there. Except for as permitted in 160. And so if you turn on over there, let's turn over to 160, 517, 160. And you see that it's titled what? Isolated power system, isn't it? Okay. And so there are some, and in here we get into detail as far as how the wire, the conductor identification equipment, circuit characteristics, isolated power circuits. Okay. And so some of this with the wiring compounds we was talking about it earlier, under number 6 there. So here's our information concerning isolated power systems as far as in a healthcare facility. Okay. If we look at our different bullet points down through there, it actually just talks about all that. I'm not going to go into detail about that. I do want to look at bullet point 1, 2, 3, 4, 5. I'd mark this one. I'd highlight this one. I think we talked about this as one of our questions, but it also may be one of your questions on your test, so I know this right here. Attachment plugs and receptacles in the hazardous location must be listed for use as Class 1, Group C, hazardous locations, and have provision for a connection of a grounding conductor. I'd mark that right there. And I know what class they're talking about. Specifically know that it's Class 1 Group C. So in this area, we're going to have that type of receptacle. And so the rest of it, the big bullet point just kind of gets in the information that we see in our code as far as specific information. I don't think that you probably need to know that, other than the fact that understanding that in this anesthetizing location, there's going to be rules that are different, mainly because people are going to be hooked to the equipment. And because of that, there's certain rules. There's actually a code section in our code book that goes into that. Now, you're going to be told in the field how to wire this if you're in the healthcare facility. But understanding, I think the biggest thing is understanding in these areas like this is care needs to be taken in your installation. connections need to make correctly. We don't want an arcing, do we? We don't want a loose wire. We don't want something to go wrong. We don't want it to be not wired correctly. And so care and attention needs to be paid in these type of areas versus like, I'm out there working in a warehouse, what am I gonna hurt? Not quite as critical, right? Okay. So as we see these, most of these are considering, and most of these we see here in the references is 517.60 as far as how wiring, and we go back to 517.60 in our code book. And 6.1, I'm sorry. We see that wiring and equipment is 517.61. And it goes into detail there. Even goes into some other things it talks about, like operating at more than 10 volts. Conductors must comply with requirements, and we see that there under number 3. Receptacles and attachment plugs, we see that under number 5, exactly what we just read. Must be used in a class 1 group C. Talks about flexible cords in number 6, and that's also listed in your book. That's that last bullet point. Flexible cords used in hazardous locations. For use of portable equipment, we're going to have that. Must be in accordance with 400.4. If you go back to 400.4, you'll see that's dealing with flexible cords in our NEC. So they have to go up to that standards. Okay. So that's that section there. Wiring and equipment installed above hazardous. So above the hazardous, we see it's listed as 517.61B. Let's turn there in our code. 517.61B. And this may get us in, well, this wouldn't be x-ray equipment. I was going to look at, and we may get to that in a minute, Dave, and answer your question. But I think it is interesting, above the hazardous location would be light fixtures, wouldn't it, for this? And that actually, if you go down to number 3, it says surgical and other luminaires shall conform to, and I want to turn to there. Let's turn to there. 501.130B. I'm kind of curious what that says. 501.130B. So 501.130B is actually talking about Class 1 Division 2, isn't it? No, I'm sorry. I'm still, yeah, am I right? Yeah, 130, yeah. And we see here, under illuminators, where lamps are the size of type that may, under normal operating conditions, reach surface temperatures exceeding 80% of the, whatever that is, of the auto ignition. Okay? We'll have to find out what that is here in a minute. Auto ignition temperature in degrees Celsius of the gas or vapor involved. Okay. Illuminators shall comply with 501.130A1 and shall be marked, type to be tested in order to determine the marked operating temperature. In other words, I'm not really curious you understand the fact, but there is a limit to the temperature that the lamp can be in this area. Is what this is trying to get at. Okay, which kind of makes sense, doesn't it? Matter of fact, we look on down through there, we see 530. Now we go 530A. Go back. A. I don't see anything. Pendant luminators. Provided with. Okay. I think the biggest thing to understand in that lamps can only reach a certain temperature based on the type of gas or vapor that is involved in that particular area. Okay. Now, I think that's enough to know about that. Wiring above, again, we go back to 517.60. That's what it's telling us in our bullet points. Bullet point number 3 talks about surgical and other luminators. Got to conform to 501.130B. That's kind of what we were. That's what we were just talking about a minute ago. Again, it's just really just kind of a reiteration of what we were talking about earlier. The last bullet point, plugs and receptacles rated 250 for connections to 50 amp and 60 amp. AC medical equipment for above hazardous location must be arranged so that the 60 amp receptacle will accept the 50 or 60 amp plug. The 50 amp receptacle must be designed as not to accept a 60 amp plug. That kind of makes sense, doesn't it? Okay. The plugs must be a 2-pole, 3-wire with a third contact connected to the insulated ground, equipment grounding of the electrical system. So it's important that these receptacles be connected. Okay. The next section there is just dealing with wiring in other than hazardous anesthetizing locations. So we get outside of that area and we see some bullet points there. It talks about, I'm not going to get into detail about that, other than the fact that when we do run, on the second column there, when we do run type MC cable, did you see there, what the note there? This type MC and MI cable must have an outer metal armor or sheet that is identified as an acceptable equipment grounding conductor. In other words, it's probably going to have a green sheet. Okay. Okay. The next thing that I would point out would be that it talks about right down below there, it says type SJO or equivalent hard or extra hard use flexible core suspended not less than 6 foot from the floor are not required to be installed in metal raceways or cable assemblies. Okay. And you really kind of go through the other same rules as far as that's concerned. Grounding, 3.1.4, grounding in this location. Static ground, we don't want it to build up. It mentions that in the second paragraph. There may be an occasion where there's a static ground, particularly like on the floor. You may have to ground the floor. Because where does your static build up? When do you see static build up? When you ever walked on the carpet, touched somebody's ear with a little static? Okay. So it's going to build up some static through the floor. Most of the time with the shoe that you're wearing and or the surface of the floor. And so what are we trying to do there, Cameron, besides fall asleep? What are we trying to do? We're trying to eliminate that static. And to do that, how would we eliminate the static on the floor? What would we do to that floor?
Grounded.
Ground. It's grounded. You may have grounding that's connected into the floor that actually removes that static electricity. We see that. I see that more in like an IT room, something like that more than anywhere. Okay. Our church used to be the worst place in the world as far as static buildup. So anyway, go back.
For some reason, my house started this week.
Did it?
Every time I touch anything, walk anywhere and then touch anything,
Might have just been some humidity or something in your
I
house.
might have been with all the cooking
Yeah. Okay.
How do they ground the floor? Do they hook it to the rebar or metal floor? Or
No, you just hook it to the ground. I mean, there's usually just a pigtail,
Oh, okay.
that you just go up to the box,
Oh, okay.
and you just, because all you're really trying to do is just hook it to the ground and goes,
Oh, okay. Yeah.
And that's usually what you do. You usually just set a box in the wall, Nate,
Uh-huh.
and it actually has a pigtail that comes and actually, but it'll be a special type of flooring that actually has
Oh,
a
okay.
ground in it.
Okay.
And you just take that up to a box, and you just take it out of the box and go up to the building steel.
So the regular
That's
ground.
all you do it, yeah.
Okay.
But it's usually it's not grounding any floor. It has to be a floor that's groundable.
Okay.
You know what I'm
Some kind
saying?
of metallic or something.
Yeah.
That's cool.
Grounded power systems and anesthetizing locations here on page 20. We can kind of take a look at that. 517.63. Let's take a look at that area right there. 517.63 in your book, in your code book, just talks about grounding. Branch circuit wiring, fixed lighting, branch circuits, so on and so forth. Okay. Talks about all, goes over the rules there. They're listed in your book. The one thing I want you to take note of, under 3.2.0, we're talking about low voltage equipment and instruments. And again, low voltage equipment, like your fire alarm and other things, got to be treated the same, don't they? The first thing you need to know is in the first paragraph. I'd highlight this first paragraph. And I know this, that if you read here, it says low voltage equipment that is typically in contact with patients. What would be something maybe low voltage is connected to a patient? maybe, you know, could be some type of, trying to think. Anything low voltage, I don't know, I can't think of anything right now, but a patient or has exposed current carrying elements must be moisture resistant and operate on 10 volts or less, I know that, or be approved as intrinsically safe or double insulated equipment. Refer to NEC 51764. You look at 51764, it is titled Low Voltage Equipment and Instruments, and it goes over the rules there concerning it. The next sentence, the second paragraph, I know this sentence. Electrical power to low voltage equipment must be supplied from an individual portable isolation transformers. You get that? Electrical power to low voltage equipment must be supplied by an individual portable isolation transformer. I know that. Uh, 3.3.0, we're just talking about X-ray. We've been talking about X-ray equipment a little bit. I would know that Article 517, which we're there right now in our code book, 517 Roman numeral 5, actually covers X-ray equipment. I know that. That's that last sentence there. Know that NEC 517 Part 5 covers X-ray equipment. And just kind of show you things as far as disconnecting means, if we're looking at it, you know, there's kind of some of the things we're looking at as far as X-ray equipment. Connection and disconnecting means, if you look in your code book, look under 517.72 in your code book. You see disconnecting means? Look at the location. This is what I was talking about earlier. Location, a disconnected means must be operable from a location readily accessible from the X-ray control. What is readily accessible?
Within reach.
Yeah, within reach, didn't it, of the equipment. So it, you know, again, most time what ends up happening is in an X-ray equipment, you may have like a partial wall here, okay? And what you typically do, and with a window, possibly. And so the operator's typically on this side, okay? And that's typically where that disconnecting means is also readily accessible. You know, because they have something, you know, because again, they don't want to be in the room, you know, where, so that, you know, they're usually looking through a window. And if I remember right, I think the disconnecting means is typically mounted right there. So readily accessible, yeah. And it's usually, X-ray equipment's usually like, I mean, 100 amp load, something of that nature, typically, so it's a pretty large load. The other thing that I want you to know there, and mark at the top of page 21, talks about, you see that sentence, individual branch circuits are not required for portable, mobile, and transportable medical X-ray equipment requiring a capacity of no more than 60 amps. I know that. No more than 60 amps. I highlight that. You might see that again. And that's per, again, that's per NEC 517.71B, and we see it listed there if you look at your code. Branch circuit not required for portable, mobile, transportation, medical equipment required not more than over 60 amps. So again, that would be a smaller unit. So that kind of tells you most of your units are probably larger than that. Most of them are usually typically about 100 amp loads. Disconnecting means, we've talked about that under the next section there. I think we've, you know, the biggest thing would be understanding that a disconnected means of adequate capacity of not less than 50% of the input required for the momentary rating and 100% of the long-term rating, okay, disconnected would be required. So that's just kind of the rules that they have in the code book. That's how they list that there. Location, got to be readily accessible. That's just how they define it there. Grounding type attachment and receptacle may serve as a disconnecting means. So you wouldn't have to have a disconnect. If it's a smaller one, it could be an attachment plug. Okay? As a disconnect means for equipment supplied by 120 volt branch circuit. So there's rule. So only, that'd be a small one there, wouldn't it? So any disconnect, I mean, only if it's 30 amps or less, and only if it's a 120 volt circuit. That's the only time that you could actually use a plug, attachment plug and receptacle. That's a disconnect difference. Rating of supply conductors. Again, you get into this 50% momentary rating, 100% of the long-term rating, whichever is greater. Box shielding is listed there at the bottom. I was talking about that earlier today. If an outlet or switch box can be installed in an X-ray area, lead shielding must be molded around the box. This ensures the integrity of the overall X-ray shield in the area. Some electricians peel the lead backing from a scrap piece of lead shielded gypsum. I've never done that. They were shielding in the boxes in the area.
Is
Really?
that something you have to wear like special equipment for because it's lead or something? You just
No,
do it,
no.
wash your hands when you're
Yeah,
done?
so that's about all. Nothing special. Okay. 3.3.4 control circuit conductors, and then the rest of that down through there. I think we've kind of, I don't think we need to read over this too much. Transformers, capacitors. We did a question on that. Transformer capacitor is part of extra equipment, not required to be part of 450 or 460. High tension X-ray cable. Not too worried about you knowing about that. Guarding and grounding. We had a question from that. Communication 3.4.0, communication signaling, data, and fire alarm. We talked about those have to be, and we see the NEC requirements that we have to go by for those. On page 23, the first sentence, isolated power systems, I know that. Isolated power systems are used to prevent power interruption due to a single line to ground fault, and to isolate power from any electrical ground in certain critical spaces. I know that right there. Now, there's some of our low voltage systems I wasn't thinking about earlier. They're shown on page 23. You know, I guess I'm not in the hospital that much, so I don't think about it. You got a pillow speaker. Again, it's just laying there. It's call buttons, call stations, patient station. You know, a lot of things there, aren't they? Probably a computer set up in the room, some type of system there. So there's a lot of different systems attached to the bed that I wasn't actually thinking about earlier. Okay. It even talks about here the nurse call. Nurse call master at stations have video touch screens that allow staff to quickly access information. That's kind of one of the things of modern convenience as far as being able to get to see what medicines and so on and so forth in the room. So get another low voltage system that may be a part of in that room. Okay. But in the isolated, going back to that, the isolated power system, what we're trying to prevent is complete loss of power. And if you read there, if you look at the first sentence there, isolated power system are used to prevent power interruption due to a single line to ground fault. Okay? So we don't want that to make us lose power. Matter of fact, if you look at, it says figure 11, so let's turn over. Figure 11, isolated power panel. You see an example of one there. Okay? Not your normal power, your panel, is it? A lot more money. Okay? But it is required in this case, an isolation power panel. So it's not going to be your typical power installation. Okay? We see here the installation for that is shown on page 24, the installation. One of the things that I want you to know is note down there at the bottom, that first bullet point, an isolated conductor, number 1. Well, let me just go back. 517.160A5, the isolated circuit conductors must be identified as follows, and I know this next bullet point. The isolated conductor number 1, orange, with at least one distinctive color stripe other than white, green, or gray along the entire length of the conductor. So it's got to be orange. I'd probably know that. That's isolated conductor number 1. Not like number 1 is in the size, but you're gonna have, so that one's got to be orange. Now look at the next bullet point. So isolated conductor number 2, which would be, you know, the second phase, brown with at least one distinctive color stripe. and the third one is yellow. Okay. Where do we usually use brown, orange, and yellow?
High voltage,
High voltage, which voltage?
277,
277, 480. Was that required by code? You think so? You don't think so?
Well.
What do you think,
depending-
Cameron?
Local jurisdiction, I guess.
It's not required by code to be colored, that color. But it's just kind of a trade acceptance, that that's what we do. And so, but code just says it doesn't have to be. Okay? But we just accept that when I go in here and I see brown, orange, and yellow, I'm doing what? I'm working on high voltage, just kind of accepted thing for the trade. Just like black, red, and blue. I mean, you don't see in the code book where it says black, red, blue, it has to be 12208. But it's just an accepted norm, it's what we use. Now, it does tell us how to identify the neutral conductor, and the grounding conductor and the grounded conductor, but you know, my knowledge, I don't see any there where it identifies the color of the other conductor, of the current carry conductors. Okay. Just accepted norm. Where now, in this case, they're specific. They say circuit number 1, it's got to be orange. Circuit number, which is kind of a little different, because we usually do 277, 280, 480. We do brown, orange, yellow. Whereas they say this has got to be orange, brown, yellow. So they flip to, you know, for whatever reason. And we do brown, orange, yellow because why? Because it's easy to remember, because you spell out boy, right? Okay. But see, and the next thing here is no wire, that's the next paragraph, no wire pulling compounds that increase the dielectric. Now what is dielectric? Let's look up dielectric. Let's Google dielectric. Let's get the definition of dielectric while we're here. Why not? Well, I can't tell you the definition without Googling it. Unless Nate knows. Let's find out.
It's something to do with insulation, but we already know that.
Yeah. Let's get a little bit more specific. Dielectric definition. Okay. Having the property of transmitting electrical force without conduction. Okay. And so, being more dielectric would mean what? Matter of fact, it says here, a dielectric material is a substance that is a poor conductor of electricity, but an efficient supporter of electrostatic field.
Is that like the magnet field that goes around the wire when you send the current through it?
I would say that it would be, Nate, yeah,
Something like that.
yeah. I'm trying to read them down here. Dielectric, insulating material are a very poor conductor of electrical current. When dielectrics are placed in an electric field, practically no current goes through. The increase refers to material that is poor conductor of electricity. Dielectric materials can be made to hold an electrostatic charge. I think it keeps going back to this electrostatic charge, which we don't want, do we? It keeps referring us back that it can hold a charge, doesn't it? And so I think that's what it's saying. We don't want the wire pulling compounds in there, because it becomes more dielectric, then it could hold that static charge more than actually having electricity flow through it. It may actually hold that static charge, which then again, if it's holding a static charge, then what's going to happen when you touch it? A little arc, right? So it kind of makes sense, doesn't it? Because like, you know, when I hold a dielectric charge, my hair stands up on my head. You just don't see it. And same way with James. But it's there. But I mean, you ever held a charge? Sure enough. I mean, you get like your hairs stand up on your arms and so on, don't you? Okay, so you're holding a charge. And the only way to release that charge is to do what? Yeah, it's to release it. And when you release it, what happens? You get an arcing, right? I mean, you feel it. You see it sometimes. You see the arcing. So that's what they're referring to there. So, and it kind of makes sense. So the increasing of that compound, we don't want that to happen, because it's saying that the dielectric can actually build up the static electricity in that. 3.5.2, third paragraph down, talked about monitors. We talked about green lamps. I want you to know this first sentence. Monitors must include a green signal lamp, visible to who? Individuals, or more importantly, workers, right? Or staff, right? I mean, you want it to be visible to the staff that's working there, right? Not just the individuals, but the staff. I'd probably know that word staff. Okay? So individuals, and we're going to define those individuals as the staff working there. In an anesthetizing area which remains illuminated when the system is sufficiently isolated from ground. So as long as it's illuminated, what? Everything's good. That light no longer lights up. We've got it. Matter of fact, it says it here, an adjacent red signal lamp must illuminate with an audible meaning what? Sound, right? Red signal lamp must illuminate with an audible warning sign when the total hazard current from either isolated conductor to ground reaches the threshold of value of 5 milliamps under normal line voltage condition. Okay? I don't know exactly how much that means, but you know, as long as the equipment knows to do that, and it's going to do that, then we know there's an alarm that's going to happen, and there's a problem. Okay? I don't know how many milliamp. I was kind of looking. I know a ground fault receptacle. Cameron, please try to stay away. A ground fault receptacle is supposed to be good for so many milliamps. I'm kind of good for this right quick. I can't remember. Let's see this. See if I can find it right quick. Ground. I can Google it right quick. I'm on. Somebody find out how much it is. They're actually supposed to not. Okay, the key component of GFI is whether receptacle form 25 k ohm resistance and test a minimum leakage of 1.9 milliamps. Okay, so this here is what would we say? 5 milliamps. So the GFI is 1.9 milliamps. So that kind of gives you a reference to something you put in every day. And so if something gets over 1.9 milliamps with your GFI receptacle, what's going to happen to it? It's going to trip it. So it kind of gives you a reference as understanding. So something that would be about 2.5 times, you know, the threshold of a GFI is what that's referred to. Kind of give you a reference to it. All right. All right. Review questions for 1 through 5. All right, read number 1.
Any location or room in which flammable, aesthetic, or voluntary flammable or dissipating agents are stored is considered Class 1 Division 1 location up to 5 feet.
Well, that's kind of what we covered, but let's read the question again. Anesthetizing volatile is disinfecting agents are stored in Class 1 Division 1. Let's go back. Let's actually look at 3.1.0. I would agree that that's what I would have thought it was to start with, because that's kind of what we studied to start with, but let's go back and look at this. Hold on a minute. Bear with me just a second. Now, this actually lists as at D, guys. And I'm trying to help us determine how we come up there, because it says from floor to ceiling. In areas where flammable are used, entire location is considered up to 11.5 foot. The area remaining up to, you see, I don't know.
Maybe they just say have 5-foot ceilings.
Maybe, Nate. I would agree with y'all. I would have put 5 foot. You might read it now, wouldn't y'all? I don't know. Anyway, don't worry about it, okay? We're gonna go up to 5 foot. NEC 51714 applies to what? 51764 applies to what?
Low voltage equipment
Yeah. And instruments. Low voltage equipment and instruments. NEC Article 490 applies to X-ray circuits and equipment over, as a matter of fact, we kind of skipped over that a minute ago, but there was a reference to the voltage there on X-ray equipment. What? 1,000 volts. Yeah. A type of non-electrified patient control device is a what?
Pull cord.
Yeah, emergency pull cord. So this is usually just what? Literally just a string attached there, isn't it? Okay. Secondary voltage for isolation transformers in healthcare facilities must not exceed what? And I'll just give you that one. It's 600 volts between conductors of each circuit. D. All right. Let's go back to all the way to the beginning. I'm going to give you some things to reference for next week. Page 1, second column, I would know that first sentence. In addition to NFPA 70, the National Electric Code, and NFPA 99, the Joint Commission, formerly known as the Joint Commission of Accreditation, Health Care Organizations, addresses emergency electrical power systems and their standards, blah, blah, blah. I know that. I particularly know that joint systems is part of that equation, or the things that govern healthcare facilities. The Joint Commission actually is part of that. Okay. Page 2 and 3 is talking about essential electrical systems. Under, let's see that. Just one minute. All right. So if I ask you the question, a TV, what load it would be, what electrical system would it be listed under? A TV, would it be continuous, essential, non-essential, or non-continuous?
Non-essential.
Non-essential. So if you had a TV, it would be a non-essential load. Critical branch. If we look here at our picture on number 3, on page 3, you see that block up there? We see EES, we got an alternate source, which is, we know, something like an emergency system. We see 3 different groups there. You see an equipment branch, you see a critical branch, and you see a life safety branch. The biggest thing I want you to know about a critical branch is that it is related, okay? It is related to patient care. Critical branch is related to patient care. So I just write that out to the side of it. Critical branch, that red little square there, is related. You're on the wrong page. I can tell by looking at you. You should be writing it right there on the next page over. Yeah. It's related to patient care. But now equipment branch is not related to patient care. So you need to know those 2 things. Equipment branch is not directly related to patient care. Critical branch is related to patient care. And we see the red under critical branch and life safety are very important. They're under a different category. Okay? They're essential electrical systems. Not only are they essential, all 3 of these are essential, but equipment branch is actually not like let's think of equipment branch, not essential. What do you think it might be?
AC loads, maybe?
What?
AC?
Possibly. How about telephone system? For sure. Let's look and see if we can find it. Let's see here. Yeah, let's look at normal. I'm reading the second paragraph under essential. The EES divided into equipment branch and life safety and critical branch. The equipment branch consists of those items that are needed to operate the facility but are not directly related to patient care. such as, oh, so that's actually a telephone system is equipment branch. The life safety branch and critical branch consists of those items that are essential to patient care. The life safety branch supplies power to these items needed to ensure the safety of the building. So it may include exit signs, stairway lighting, alarm system, communication system. So that's under one of our red areas, isn't it? Whereas the critical branch supplies power to areas that are directly related to patient care. These include pharmacies, emergency rooms, intensive care units, and so on and so forth. So I just kind of know that whole paragraph, understanding the difference between equipment branch, critical branch, and life safety. All right, page 4. Any area requiring electrical life support equipment is a what type of classification? Page 4, 1.1.1. Any patient area that is electrical life support system equipment would be listed as what type of?
Type 1.
Type 1, thank you. Type 1, EES. Type 1, EES meaning what? Essential electrical system, right? And so that would be type 1, life support. Okay. Page 6. Under other healthcare facilities. Just that whole paragraph there. Facilities do not require type 1 or type 2. Emergency power may be provided. Batteries are required. This is the part I know. Batteries are required to maintain the emergency load for what? 1.5 hours. How many minutes is 1.5 hours? You might want to write that down. 1.5 hours is 90 minutes. Okay. The next down, spot network, you need to know that. Sometimes, just kind of reading there, spot networks are considered the most reliable and flexible arrangements. Ideally, these feeders are installed in parallel so that the fall of one feeder will not affect the other. So in other words, if you got like a dual, not double-ended, but if you got like a dual setup, that's called a spot network, okay? So if they were to ask you the question, if you got 2 or more distribution points, what would it be called? It wouldn't be called a double-ended system. It would be called a spot network if they were to ask you that question. On page 11, hospital grade receptacles. Second paragraph, first sentence. Hospital grade receptacles meet nationally recognized testing laboratory criteria for superior electrical characteristics and mechanical strength. I know that. I know that right there. On page 13. In a patient bed non-critical space, which is listed there on page 13 about right below those 3 bullet points. In addition to 2-branch circuit, each patient bed location must have a minimum of 8 receptacles. That's in a non-critical space. You got to have 8 receptacles. Now if you go on down there on the same page, all the way at the end, in an operating room has to have how many receptacles? How many receptacles must an operating room have?
36.
36. I know that too. I know those two numbers. Bear with me just a second. Let's see. On page 14, talks about, at the bottom there on the second column, MI and MC cable. You see that sentence there? I know that. That MI and MC cable must have a healthcare facility rating. I know that. Be clearly marked as such and terminated using illicit fitting. You know that sentence right there. I think that'll cover us, guy. We done gone over, I done told you what to do on section 3 as we went through that, right? You got all those. Okay. All right, let's do review questions, page 26 and 27. Let's see if we can answer these. You want to take a break or you want to keep going? Good? Everybody good? Keep going until we get done? All right. Review questions, page 26 and 27. Electrical work in healthcare facilities is governed by what?
517.
517B. Which of the following provide around-the-clock services to patients? Just read through those and tell me. Which of the following provide around-the-clock patient service to patient? Hospital, nursing homes, ambulatory, limited care, nursing homes, ambulatory, limited care, ambulatory, healthcare facilities, hospitals, limited care, hospitals, and nursing homes. Which one do you think? Well, that's a hard one. But if you had to guess, which one do you think after you read through this?
D.
D, is that what you said? Very good. You got it right, D. The life safety branch for a central electrical system would include what? Intensive care units, patient care spaces, pharmacies, or exit signs. Life safety branch, we talked about that a minute ago. What would that include?
Exit sign?
Yeah, it would include exit signs, exactly. Because we don't want to be able to see how to get out, don't we? The maximum, now you probably wouldn't know this, we could look it up. I'll tell you where to go to look it up if you want to. Or we just kind of look at it together and come up with something. The maximum time allowed for transfer switches return to operation within an emergency power system. We read that actually a couple of weeks ago. Anybody want to take a stab at that?
10 seconds.
10 seconds, yeah. Okay. The maximum demand of a facility with only one transfer switch as an essential electrical system is what? I'll tell you what that one is, 150 kVA. Which type of facility must have a type 2? Now type 2 is not quite as stringent, is it? It was like limited care and things like that. And so by looking at those, what do you think a type 2 EES would be of those four things there?
Nursing home.
Nursing home, yeah. Throw-over switches, in something to swap power, are often used to allow temporary operation of what? What do you think would be used to try to get out of facility?
Elevators.
Elevator, yeah. In a type 2 EES, which of the following must have alternate power placed within 10 seconds of a power failure? Storage areas, medical and preparation areas, exit signs, or heating equipment?
Medical.
No,
B.
it would be C, exit signs. I think we want them to come on, don't we? Yeah. Where branch circuit panel boards for normal and essential power serve the same patient care vicinity, they must be connected together with an insulated copper conductor no smaller than a what? I remember us going over this.
Number 10.
Yeah, number 10. Outlets that are in emergency power are often identified by
Color.
color. Most of the time, a hospital grade is what? More than likely, red. But the dot on it would be what?
Ground.
Green, right? Dot on the hospital grade receptacles, green. Hospital grade tamper-resistant receptacles, what?
B.
No.
No, A.
A, yeah, you only want it to be energized when everything is plugged in, right, simultaneously. So, hospital grade tamper-resistant receptacles must be used where?
Saturated locations. A.
A, psychiatric, crazy people, like you, Cameron. You know, one of these days, we might find you there. Okay.
Mine.
Psychiatric location. Bull Street in Columbia. That'd be one of them, where the psychiatric hospital is down there.
There's one over here near a shop.
Is there?
I got a friend of mine works there,
Oh, really?
works down at Looney Hall, yeah.
Yeah.
We gotta do some work down there.
Did you? Each patient bed in a general patient care space must have a minimum of what? 8 receptacles. In an area where flammables are employed, class 1 to div 1 location extends upward to a level of 5 foot. You see, it contradicts itself there a little bit. I guess it's just the way that other was worded, and the fact it's flammable anyway. In order to use a suitable attachment plug and hard service cable, X-ray equipment supplied by branch circuit must be rated no more than what? We read that just a minute ago.
60 inches.
Now,
30.
30 in. 30 in. Okay. All right, let's see what, anything else we're gonna go over before we take a test next week. I think that's about it, guys.
During the eclipse, they took.
Sir?
That friend of mine, during the eclipse, they took the patients out onto the garden area to look up
Yeah.
at the sun, gave them glasses and everything. And all the patients from the psychiatric ward started howling when the
Did they
moon started
really?
coming.
Really? All right, so the test next week, we'll go over that, do that. Nate, if you can think about it, if you could find your number.
Yeah. You gotta go look it up at the house. I gotta
Okay.
get those certificates.
Try to remember to bring that back with you next week, if you could, please, sir.
Did I get mine right?
Is that on there? Is your number on there?
Nope.
No. I didn't think about looking on there. You do need to make some copies of that, and turn it into your work.
Yeah,
Just kind of give you, before y'all go, just a memo that I got. Y'all may want to write these dates down. All right, so just kind of looking, just so you'll kind of know. Yeah, 'cause we got a little bit of time, so let's talk about this a minute. So let me look at the calendar. Just kind of let you know what's going on for the month of December and January, so y'all kind of know this, okay? All right, so looking at December, so we will have class on the 4th, okay? All right, which would mean we're taking our test, is that right? Yeah, taking our test. On the 11th, we will have class. On the 18th, we will have class. And I'm looking at this thing here. College will be closed between the 19th, so we will have class on the 18th. So we got class 3 weeks in December. The school will be closed from December the 19th through January the 2nd. So that means we would not have class on the 25th, which is Christmas Day. I would hope we're not. And we would not have class on January the 1st, which is New Year's Day. Okay. But we would have class on the 8th. So that's when we'd start back. But then you get a little break, because on the 15th, Martin Luther Day. So we won't have class on that day. So December, we've got it the 4th, 11th, 18th, so one day in December we'll be missing, which is the 25th. We'll be missing the 1st, we'll come to class on the 8th, we will not come to class on the 15th, and then after that, we'll kind of get back on a normal schedule. So if y'all want to know that stuff. in case you miss a day or you're out or something. So somewhere along the way, we would probably be, let's think about this. So if we're doing, I'm just kind of looking, so we're doing the 4th, so we're taking a test. 11th, we'll be actually doing session 1 of module. On the 18th, we will be doing session 2, which means when we come back on the 8th, we would do session 3 of generators, or standby and emergency systems. And which means then the 8th, then the 22nd of January, we'll be taking a test on module 3, if that makes sense. So you've got 2 weeks to do your homework. So your homework in 2 weeks, homework for next week is to study for the test. Your homework in 2 weeks is to do that homework paper that I give you and to read session 1 of module 3, which is 1.00 through 1.23. So that's your homework for 2 weeks. Okay. But next week we'll have our test. And we'll go over it after, kind of grade it ourselves and go over it, review it, kind of go do that stuff, and then the week after that we'll start. Okay? All right? Understand? Everybody good? Everybody on the same page? What we're doing? Well, we won't be here in case you missed something for some reason. You know, don't come here, you know, on the 25th, because Ronnie ain't gonna be here. Good. All right?
Yeah, I was so worried about today because we were boring. I had boring guys out there, and I was afraid they was going to stay late and try to finish today. But,
Oh, really?
Yeah, but they're coming back tomorrow. You know, go easy,
Yeah.
like I don't want to miss no more classes.
That's right. Okay. All right. Y'all have a good one.